Okay, so this lesson is 6.1.5. It's called Converses. What Converses is talking about is how to reverse a statement. So, for example, if you say, hey, this right angle measures 90 degrees. So if it's a right angle, it measures 90 degrees. So Converse says if it measures 90 degrees, then it's a right angle, right? So Converse means to switch the sentence, switch the hypothesis and the conclusion, switch the beginning and the end, and see if it's still true. And a lot of times when we're talking about Converses, we're looking at a true statement. Obviously, there are untrue statements. For example, it says if it's a dog, it's an animal, right? Well, that's true. But if you switch it around and say, hey, if it's an animal, it must be a dog. No, not all animals are dogs. So, of course, you have to look at the validity and see how true it is when you switch the things around to make it a converse. The converses we use in geometry are typically statements that are true, that are going to work both forward and backward. So these are very powerful statements. For example, we say, all right, if it is a right triangle, right, then the Pythagorean theorem works. It says that a squared plus b squared must be c squared. Does it work as a converse? If a squared plus b squared equals c squared, then is it truly a right triangle? And the answer is yes, it is true. Okay, so look at a few things here. On the first problem here, it says Jorge is, or George is working with the diagram at the right, and that concludes that AB is parallel to CD. He writes the following conditional statement to justify his reasoning. If alternate interior angles are equal, then the lines are parallel, right? So I'm saying, I look at this picture and say, oh, I do see alternate interior angles. Remember, alternate interior angles are on the opposite sides of the transversal, and they're on the inside. And that's only true if A, B, and CD are parallel to each other. So that's very good, right? So when we had it back in the previous chapter, we said we have parallel lines, therefore alternate interior angles are congruent. Now we're going backwards. Alternate interior angles are congruent, therefore I have parallel lines. That's why this is a converse. Okay. Martha is working with a different diagram. She concludes that x equals y. So x equals y. Okay. Write a conditional statement that justifies her reasoning. So she is saying, she looks at it and sees, oh, I see parallel lines and these are congruent. So this is going back to what we learned back then. We're saying, well, if, this is her reasoning. She's saying, if the lines are parallel, then the alternate interior angles are congruent. This is what we learned, right? So how are George's and Margaret's statements related? How are they different? So again, see how it starts with alternate interior angles and then they're parallel. And then Margaret says if they're parallel, then they're congruent. So they are exact opposites of each other. So what we are saying here is the hypothesis, or the beginning of the statement, and the conclusion, the ending, switched. Okay, so they switch places. All right, so now let's see if we can figure out more of this. Conditional statements have this relationship, are called converses, meaning that if I can take the beginning and the ending and switch them, these are called converses. So let's see if we can write more converse, right? It's a practice on how to read converse and how to write them. So let's write converse of the conditional statement below. If the lines are parallel, then the corresponding angles are equal. They're congruent. We talked about this, right? We know that we have parallel lines, the corresponding angles are equal. So let's write the converse. So we're going to start with the back. We're going to say if corresponding angles, remember you can use shorthands if you want, are equal, then the lines are parallel, right? So this is the converse. Okay, so now this next statement. Are all converses true? We're talking about this before. Consider the arrow diagram of a familiar statement. So this arrow says we start with if. If the triangles are congruent, then the corresponding sides are congruent. So if I already know that these triangles are congruent, then all the sides, the corresponding sides, are they also congruent? Is this statement true? Yes, right? We know that congruent triangles, and we proved that in the previous lesson. We listed that if we know the congruent statement, then we can start talking about, okay, AB is congruent to XY, BC is congruent to YZ, and AC is congruent to XZ, XZ. So you can know that the corresponding sides are also congruent, right? So write the converse of this arrow diagram as an arrow diagram or as a conditional statement. Is the converse true? So we're going to start with the conclusion, right? We'll say corresponding sides are congruent. So if corresponding sides are congruent, that's where the arrow says, then the triangles are congruent. Is this true? Yes, we know this is true because this is really side, side, side congruence. If I know all the three sides are congruent, do I know that the triangles are congruent? Yes, we do. So that's how we prove side, side, side as well. Okay? All right. Now consider another congruence conjecture below. Write its converse and decide if it's true. If it is true, prove it. If it's not always true, explain why not. So it's saying triangles are congruent. If the triangles are congruent, then the corresponding angles are congruent, right? So again, you can draw a picture for yourself. I'm gonna use the space up here. I'm saying, hey, A, B, C, and X, Y, Z. So if they're congruent, then the corresponding angles are congruent. Okay, we know that that's true. Now let's talk about converse. Let's switch it out. So we're saying if the corresponding angles are congruent, then triangles are congruent. Is this true? Is having angles enough to prove triangles congruent, right? Think back to all the congruent statements we had. We had angle, angle, side. We have angle, side, angle. We must have a side to prove the triangles to be congruent. If I only have angles, that's not enough. Only angles only prove similarity. So I would say, no, it is not true. So this is false because angle, angle, if an additional angle helps, so angle, angle, angle only proves similarity, not congruence. Okay, so again, make sure you read through what you're putting down on your toolkit and make sure you are writing down what is true and what is not, right? Angle, angle only proves similarity, and feel free to put that on the toolkit as well. There's a lot of empty spaces there for you to put the other things. Okay, all right. Write the converse of the diagram below. Is this true? Justify your answer. So if a shape has a rectangle, then the area of the shape is base times height. Okay, if the area of the shape is base times height, then the shape is a rectangle. Is that true? Is the only shape that has base times height a rectangle? Think, pause, think, and the answer is false. There's another shape that is not a rectangle but also base times height. So I say false, and if you recall who else has a base times height? Parallelogram. I always have to pause a little bit before I spell out parallelogram. Parallelogram is also base times height, but not a rectangle. Not always a rectangle. Okay? All right. So again, please take a look at the methods and meanings, read through them, figure out the theorem, figure out the converse. Basically, a converse statement is just switching things around. And again, through our lesson, you can see sometimes the switch around statement is true, sometimes it's not true. So you really have to look at what is being presented in the statement and figure out if you can find a counter example, an example that proves it wrong, to figure out whether this is a true statement or not. Okay? All right, that's it, guys.